All right, testing, testing. Do I have audio? I seem to have audio. Deimos Anomaly in the chat says Madrigal live. Yes, indeed. Oh, now it says message retracted. That's strange. Anyway, Deimos Anomaly has the honor of writing the first live chat message on our channel. Hello, Rogers. We actually have some people here. That's awesome. Yes, so needless to say, I am new at this whole live thing. It only took me like 6 years after establishing the channel to actually do this whole live stream thing. Let's see what comes out of it. But I'm happy to actually see people here already. I wasn't sort of expecting that to be the case. Anyway, hello everyone. Did you get yourself a beverage? Let me know if the audio levels are all right, or if you would like me to change them somehow. The room that I'm recording these things in isn't perhaps the best audio-wise. But I hope that we can manage. Right, so let's just undo my text here that I wrote earlier and get started with some actual things. Maybe some more people will join, maybe not, and I'll probably put this up as a VOD anyway. So my plan for tonight was to sort of do a little bit of more active and transparent development of Traction Point, because I'm trying to sort of pick up the speed of actually developing the game rather than just rambling on about different kinds of tech things that I use to build the thing and the basis engine, and actually sort of concentrate on the actual game for a bit. And of course, one of the goals with that whole thing is to actually get something that you guys get to play somewhat soon. And so anything that pushes me in that direction is good. And today we're going to try a little bit of live streaming. If you have any questions, just let me know in the chat. Happy to answer them as usual. I did have a sort of an agenda for tonight. We're going to look at these glowing things here on the ground. We have one here, and we have another one here. And these are kind of central to the gameplay of Traction Point. These are called interaction areas. And I've been writing them, well, actually not super recently. I've done a little bit of other work recently, but I started writing these, and let's see if we can actually somewhat finish them today. Perhaps not. But just to give you a very quick overview of what we're dealing with here. If you have this monorail thing that we've looked at in previous videos, and the monorail happens to be in the other end of its rail, you need some way to actually sort of call it here. See if we can actually run this. This is not my main development computer, by the way, so things might be a little bit out of date. Sometimes I forget that I need to bring over some data or something. And that can cause things to go a bit sideways. Right, so if we have the monorail avatar, and here we have another thing that is sort of a little bit in progress because we don't have those collisions for the ramp yet done. I'm just gonna lower my local volume a little bit for the game itself. So you can see here down in the lower right corner, whoa, what is with the frame right there? In the lower right corner you have this text here, that we have entered the interaction area. Wow, there's something really strange going on with the frame rate. Yeah, let's hope it doesn't ruin this for us. And when you're entering this area here, you're supposed to be able to control something. In this case, probably the monorail. And these can be of various sizes and shapes. So here we have another one that's a round one. You can essentially just select this and move it around, and it sort of tries to stick to the ground. And move it upwards a little bit. You can see that it even tries to sort of go over this pipe here. It doesn't quite manage to do that, but of course you would never want to have an interaction area that looks like this. This is kind of silly, but you might very well want to have one that follows the shape of the terrain a little bit. So that's what this is. And you can make it a box. You can make the box bigger and rotate it, etc., etc. And this is controlled by the Zig component. Let's see if we can find our interaction area component. Is right here. So if anyone has happened to stumble upon my channel without having seen any of this before, I'm building a game in Zig, in the Zig programming language. I am building it using my own game engine called Basis, which is actually not written in Zig. And this is the Basis game engine's editor. Now, the reason I don't have an editor written in Zig is that it takes quite a long time to build these things. And I've had Basis for a number of years. And now I'm building a new game, and I'm sort of exposing things to Zig as I go, with the intent that the game code itself is in Zig, while most of the tech stuff is still C++. But we have a fair bit of stuff ported over to Zig now, and here we have the interaction area component. And the text that we saw earlier, that comes from something that we have down here, if I remember correctly. So on object entered, on object exited. Yeah, we have a physics trigger that we have, like an enter callback and an exit callback. And it's hooked up to these guys here. So when an object enters the volume, we call server interaction manager object entered interaction area. And here's the actual trace that we saw. So the text. And yeah, this is kind of where I figured we would continue building this thing today. So if you're wondering what these autofix things are, Zig has this feature where it doesn't allow you to ignore a parameter of a function. So if we create a function called, well, probably can't be called test, it's called test function, and we give it like a number, like this, and then now if I save this, it will add this line like underscore equals number autofix, and this is just like a signal that, oh, this was auto-fixed, because you're not allowed to actually build without, like, you can see you get an actual like compile error here, unused function parameter. And yeah, when you're working with like callbacks like this, you tend just to have a pretty rigid set of function function signatures that you're working with, sort of doing a little bit of exploratory work. Zig is not the easiest to work, easiest language to work with in that sense, because it sort of prefers you to like use this automatically, and so it adds these autofix lines here. But as soon as we start to actually use these parameters for something, they will go away, and they will go away automatically, which is kind of nice. Like if we just do like, you know, basis print. I can't actually use that, but I can do print f like this, and then like, I don't know, area or something. Then the autofix line goes away automatically. So that's kind of nice. Anyway, that's kind of a ramble. I wanted to get something done today in something like the concept of when the player enters one of these areas. Let's move it a bit closer to the starting vehicle, which is right about there. Now this area is not obvious what this area is connected to, and that this is not really how you're supposed to place these guys. They're supposed to sit right next to something like this guy here, which is sort of, it might not be obvious yet. This might not be the final visual representation of it, but if we put it like this and you drive into that, then it's kind of obvious that it actually controls this monorail here, right? But if we have this one here, which sits right next to the vehicle, just that we can quickly test this guy by just driving into it. The goal for today could be as simple as just showing something on the screen while when you are in this, something like, you know, press E to activate or whatever is going to be. It's going to be shown. The actual message doesn't really matter. That sounds like a pretty easy thing to do, but it gets quite a bit more complicated due to the fact that Basis is a client-server system, and the physics triggers live on the server, while the HUD lives on the client. So that makes it a bit more tricky to actually do these kinds of things. We need to make the client sort of aware of what is happening on the server. But it's not super tricky. It's just something that we need to keep in mind when doing these things. So how would we do that? Well, we use RPCs, or remote procedure calls, to do that. And this is an area where my systems aren't perhaps the very best in Zig yet. So let me demonstrate. If we go into where do I want to go? I want to go to Basis. I want to go to Means. And Means is the code name for the Traction Point game, by the way. So that's why you see it here in the Visual Studio Code namespace as well. We're working in the Means namespace. And here we have RPC. And the RPC system is something that it's completely custom. It's kind of sort of based on C++, kind of sort of, and it is designed for C++. Yeah. So here we have an interaction manager RPC unit. You can see here that we are in the interaction manager type here. This can sort of be considered a singleton, except not really, because a singleton is something that you have only one of in a game. It's sort of like the one and only instance of a type. The interaction manager is kind of a singleton in the sense that you're supposed to think of it as one thing, but it has one representation or one instance on the client and one on the server. And so in Basis, even if you're working in a single player environment, you're still running a client and a server. And if we go to the interaction area component, so this is a game component. You can think of these sort of like mono behaviors in Unity. The concept is kind of similar, and you can specify where we actually want to create these guys. We do that here in the asset browser. We go to blueprint and we go to gameplay blueprints. We have the interaction area here. So the interaction area is created on the client and the server, and also in the level editor. And that's what gives us this nice glowing ring here. Here's this icon thingy. That is this editor icon component. But yes, so we have an interaction area component. It's created on both the client and the server, and that means that the server representation of this guy, if we go a little bit down, we can see here create. If we're on the client, we do all of this. We essentially set up the render object. If we're not on the client, first of all we register this interaction area with the manager that we just looked at. And this is literally just, well, it doesn't even do anything yet. As you can see, this is where we just were when I talked about the auto fixes. But essentially the area tells the manager that, hey, I am here, I exist, and passes its own self pointer to the manager. But if we go a bit further down, we have on created, create area. And in the create area here, we have an on client, which actually then calculates this render thing, or just loads it from data. If we're not on the client, we're on the server, and this is where we set up the trigger. So yeah, we have something called a game object trigger, which is actually sort of a wrapper around a proper physics trigger. But it just means that rather than just reporting every single wheel and part of the suspension and everything that has like a physics representation for one game object, it just reports the game object as it enters and leaves as one whole thing. And we check if it's a box. If it's not a box, then it's a sphere. And so this means that since we do this only on the server, we also only get these callbacks on the server. And if we go back to the interaction manager, so this is an IDL file, or interface definition language. This is a completely self-made up language. These are essentially sort of C++ function calls without the return value. That is because this started as a sort of a C++ thing. And I have a tool which actually generates C++ or C# code out of this. If we go have a look here, the interaction manager, you can just run this batch file here. And it creates a bunch of files for us. It essentially generates the RPC code for us, so that we don't need to serialize or deserialize anything ourselves. So we can see here, called by the clients, called on the clients by the server, right? So show interaction prompt. This is something that I created earlier. This reliable just tells us that it's supposed to be like a reliable network message. And that is essentially where we can then show our HUD things, because it's called on the clients. And of course you can have multiple clients if you're running a multiplayer game by the server. So server calls this and it gets executed on the client. But we can of course just sort of think about this in the terms of a single player game now, so it's really sort of just like the client. And what this generated code looks like, it's not very tricky. It is kind of boring, and that's why I wanted to generate it in the first place. So I call the something that you have if you want to call an RPC on another machine. I call that a proxy. So the server, when the server wants to call something on the client, it has a proxy and it runs things on the proxy, and that makes them magically execute on the client. And the other way around as well. The client has a proxy for the things that it wants to run on the server. And yeah, you can see here, this is generated by the basis IDL compiler. This is the code that it generated. So it creates a message. It has some auto-generated IDs here. Or well, auto-generated. This is just like linearly increasing number, so not very high tech. It puts in a channel ID, which is something that we give to this so that it knows like where in the game it is going to go, because we have like literally hundreds of RPCs. And then it puts in the ID for which RPC are we actually calling here, and then it puts in all of the parameters, right? And this gets serialized then and sent over the network. And then the other side, it doesn't have a proxy in this sense. It does have a proxy, but it's used to call the other way around. But it has something called a stub. And the stub is also auto-generated. It's also very boring. It's not very complicated at all. But it does essentially the other thing in reverse. So you have on RPC received, it does some filtering here to figure out if the thing that was sent is actually does belong to this guy or not. And then it just has a big switch case. So it puts the parameters on the stack, gets them out of the message, and then calls this. So the target better have one of these functions here, or it's not going to work. Now the problem with this is that I can't actually generate Zig code from this yet. I can generate C# and I can generate C++. And for example, whenever I do all of these things in the editor, these are all just RPCs sent from this C# application to the C++ side. So all of essentially anything that is carried out, all the commands in the editor, for example, are RPCs. But yeah, I haven't gotten around to actually building the Zig part of this yet. But I still have this interaction manager here, because this is kind of neat in the sense that I need to write this by hand, but if I then submit this and I make a change to it, I get like a nice diff, so that I know what did I do and how do I need to change it by hand. And of course later on, if I actually get around to implementing the Zig generation, then it should work just out of the box with the IDL file that we had. So you don't have to watch me, at least hopefully you don't have to sit there and watch me type this. I did it already. So here we have the same thing in Zig. It does essentially just exactly the same thing. So put in the channel, put in the ID for the show interaction prompt, put in the parameters, and send it. And the stub does the opposite. Just a switch case here. So pretty simple stuff. We should sort of have everything we need to be able to call this. But I haven't run this, so I don't know if it works. Well, let's see if it does, shall we? So in the not the campaign manager, but the interaction manager. So this guy is initialized both on the client and the server, and we saw earlier that the interaction area component here in the onEntered. This is of course running on the server, and so we use the server interaction manager, and we call object entered interaction area here. So here, this is where we would use probably then the RPC proxy, which I added there. I'm calling show interaction prompt with the player host ID. Now some of these things I kind of ported straight over from previous game I did, Project Slide. So we might want to actually have a look at why I did some of those things, and then sort of think about do we want them for Traction Point or not. But we might want that, and I can show that to you. We can go into the C++ side. So we have a solution here which covers both the actual runtime for the engine, which is pretty huge at this point, annoyingly so. And then we have the games. So here we have Slide, and we have got the gameplay. We also have an interaction manager here, like this. And this works kind of similarly, but not necessarily exactly similarly. So there are no interaction areas in Slide, but you can essentially like drive up to another vehicle and switch to that vehicle. See if we can actually we can demonstrate that here. Let's load the Slide data. This goes through and converts the data for us if something has changed, and we can see if we can actually run Slide directly here from Visual Studio. Right, so the code is converted. Again, I don't use this machine all that often. So right, I can't link because I have it in use here in the editor. Let's unload the backend, so to speak. Try to build it again. And see what we get. All right. Nah, we don't need to use the web GPU. Oh. Yeah. Yeah, that's not great. I need to be running it off. Let's see. Blah 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 blah. Yeah, why is it complaining about an SVG version? That's kind of annoying. I should probably reconvert the Slide data, but let's do something different. I think I had a pretty recent version of Slide here, just ready to go. It's not super recent actually. Plane and cars. That should give us a pretty good idea of what we're talking with here. And again, my volume is just way too loud. Right, so if we have a vehicle like this, you can just drive up to another vehicle, and if you're close enough to it and your velocity is low enough, you get this press E to switch vehicle, and you can see this green kind of faint circle around. So this was really just like a debug. I didn't get very far with this game, to be honest. Really just like a debug indicator of which vehicle you're switching. So you can do things like this. Switch between these two guys. Now we can blow things up as well. Yes, so this is sort of the same thing in that sense. You go somewhere and you get some sort of indication that you can interact, or you can switch, or you can do something. And yeah, we will want that for Traction Point as well. So it should probably work kind of similarly to this. And you can see here I actually did have like a client server singleton. So it sort of wraps the singleton idea, but makes it so that you can actually have two instances rather than just one. But of course, Zig doesn't have any base classes or anything like that. It doesn't even have class. It just has structs, no inheritance. But the concept is sort of the same. All right, so this is called from a server player controller when they want to interact with an object. All right, so this is probably like what we used there too. Yeah, it has like the switch vehicle case handled here, and we just simply set the avatar object to the target object's name hash. Right, and here we do like register vehicle. It's kind of the same as we have here with the register. What was it called? Like the interaction areas. We're pushing them to a list like this. So something similar we'll want for interaction point as well. Let's see here. Show interaction prompt. This is essentially exactly the function that we were looking at here. Show interaction prompt. This is called by the server on the client. So what did we actually do here? We're getting the interaction type, and what is the interaction type? That's like okay. So yeah, I had some other things here, but never really got that far. So we send a message to show the interaction prompt, and I bet this just basically shows the let's see. There's the sending and there's the case. Yeah, so read a param specifying what kind of interaction this is. So currently we just show something in the HUD. Okay, that's fine. Technically it's this one that we're showing. So this is an in-game UI view model. We also have this in interaction point. In-game UI view model like this, and we can, as you can see, we can also react to messages here. So this is probably where we will want to put in that thing. Yes. Excellent. Any questions? If not, then we're gonna move right along. And the first thing that we'll want to do is we want to go in here, and I think the first thing, the most basic thing we can do here is basically just check. Okay, so an object entered an interaction area. If that object is the avatar, which is sort of basis speak for, is this object the thing that the player is currently controlling, in other words the car, then we can just call this show interaction prompt. And when it leaves, we clear it. That's like the minimum viable version of this. We don't even really have to do anything with these interaction area thingies. So so how do we do that? Well, we would need to somehow get probably the game session, right? The game session is the thing that knows who is represented by whom. Do we have it here? We kind of don't. It sort of looks like we don't. Yeah, I don't have all of these things in logical places on the Zig side yet. I haven't really needed some of these things previously for a whole lot. Yeah, I was thinking the means app would have it, because the means app is the thing that actually here you can see create interaction manager. If it would have the the knowledge of who is the game, the player avatar. Let's see, game session. Actually, we can just do search for avatar. Who actually knows about the avatars? Oh, it's probably like it's a game master component. Yeah. Yeah, so this guy, the game master, is sort of like an object that is created as the very first one, manages a whole bunch of things, potentially. And this guy knows things. This guy has seen things. So there's a map, a hash map essentially, where the key is an integer 32 and the value is a player data. The player data has the avatar name hash. This I32 is the host ID, which is like a number that every player, every client that joins a game gets. So it never changes. So you can sort of uniquely identify a player by their host ID. So that's cool. That's cool. I did have some other avatar logic though that we might be able to use. Vehicle avatar component. Yeah, this guy does all kinds of things. Yeah, I should maybe have researched this a bit better before starting the stream, but oh well. Who has the time for that kind of thing? What do we actually use this guy for? Oh, init vehicle debug. Well, that's not super helpful. Yeah, there's something called set SP avatar, right? No. And that's probably on the C++ side then. Yep. Right, it's a script. Yeah, it's a script thing. SP avatar. Okay. And who has... Oh, it's a game state. Yeah, game state. No, not game session. It's the game state that knows the avatar. Game state. Game state here. Set avatar object. Okay, here. Oh, well. Right, here we can set it. So we set the object hash name and the host ID. Okay, and then we can clear it. But annoyingly, we can't actually ask the thing if they are the object. So to give you a little bit of background here, what I'm trying to figure out here, what I'm trying to solve is that when something enters one of these areas, it's just any game object, right? So if you like nudge like a box into the area, this will get fired for that box. Obviously, we don't want to show a HUD element if that happens. We only want to do that if that is currently the single player avatar, but essentially like any player's avatar. Then that player should get the HUD message that they can press E to interact, essentially. So, what is the easiest way to get that? The easiest way might be to actually just ask the game master, right? And to get the game master, we will need to get the game state. It's kind of annoying that I can't get the game state outside of a component currently. Search for game state ptr. Okay, you can get it from the client. Alright. That's good, because then we can get... Yeah, that would work. That would work. Out of the game state, you can get the game object, so we can get essentially the game master out of that. That's fine. Let's make sure. Let's do that. Let's just make sure one more time that I can actually get it out of the game master component. So the game master component, it has this. We have two of them actually. We have campaign game master component, and we have just the normal game master component. We might want to actually build some sort of small logic for ourselves here that we can actually get the avatar in a bit easier fashion. But yes, so player data. It keeps track of the player data. Yeah, but it doesn't really do anything with it. Okay. Okay, that's fine. Yeah, and the campaign game master component does sort of the same thing, right? Yeah, okay. So this guy knows who the avatar is, and we can at least, like in theory, ask them who the avatar is. And how would we do that then? What would be the easiest way? How did I do it in the interaction manager here? Avatar. Target vehicle. Oh, right. Yeah, this is how we want to do it actually. Yeah, we don't need to go through the game object master at all. What we can do instead is we can register that we are interested in messages being sent to the interaction manager when the avatar changes. Absolutely, yes. That is actually how we want to do this. And that is how the C++ side does it. Yes. Okay. So yeah, this happens when enough time passes between you writing a piece of code and then you needing to actually remember that piece of code. So these are messages. They are defined in C++, but we can listen to them in Zig because they are really just enums. There's nothing special about them at all. So avatar tracking messages. They belong to a message category called avatar tracking as well, and there are set, clear, and local avatar updated messages. So we can just tell the system that, hey, we want to subscribe to this message category. And then we essentially listen for these two messages. And then we know who we are, essentially. So let's do that. And the way that we listen to messages in Zig is via a message node. Message node, which looks like this. So anything can have a message node. You create it and you register it. You create it with the host, yeah. So that's the client or the server. And then you can send messages, and you can also listen to messages. Do we have a? Yeah, here's an example of the in-game UI view model that we looked at earlier. So this uses it both to send messages, but then also to listen to messages. So on message received, you just register it with the message node like this. Okay. So that will work. That will work. Let's do that. Let's add one of these guys to the interaction manager. We have the host, which we can use to initialize it. So it will be a-okay. So we do const message node. I'll just shorten this a little bit. Message node like this. And then as a member of this class, we just do a message node. And this is a pointer. These are always pointers. And you can do this in Zig. Like this will not compile. Let's try to build this and see what happens. It will go like, nah, nope. So expected type pointer to message node font type of null. We need to make it an optional if we want to actually use null here. This would work. But then we need to actually check that it's not null all the time. And that's kind of annoying. So for these sort of objects that I sort of know the lifetime of pretty well, they're pretty well defined. I typically just use undefined instead, because I will almost immediately set this to something. And here actually, perhaps I can just leave that out, because we will, yeah, this is the init function. This is essentially like the constructor of this type. Yeah, here I can probably do this. I can do var message node equals host create message node, and we need to give this a name. So let's give it like if on client. Oh right, we need to on client is set there in the switch, so we can just do we can do message node here, and that will be a pointer to a message node. Undefined. And then here we do message node host create message node, and we call it, we need to give it a name. It just needs to be unique, so that if you can sort of ask, hey, who sent me this message, then this needs to have like a unique key. And we can just simply call this client interaction manager, right? Like so. And the same thing for the server, obviously. Like so. And then we just need to actually give that to the actual object that we create. I'm gonna restart the language server here because it seems to be a little unhappy with me. Right, so here we just created a local variable. This is not the same as this one. So here we are assigning the local variable to this one. Right? And then in the dinit, we need to quite simply dinit that message node as well. All right, now the language server seems to be back alive. Right, there's a post init here as well, and this post init is important because this is where we can actually hook up callbacks. As the comment says, this must be called in the campaign manager when its final address is known. As the RPC proxies and stubs needs to have stable addresses to set up the listeners. Like here we are creating an interaction manager, but then we're just returning it. So like this is just a temporary variable here. Post init is called from means app. Like here, when we actually have the final one. So in here we can set up the on message received callback, and I think oh, that's campaign manager. Well, that's not the right one. Interaction manager. Here we go. I think yeah, I have a snippet for that. something's wrong with my snippet. What is wrong with my snippet? Message. Yeah, that has changed at least. It's no longer a pointer. It's like an actual type that's a pointer. Message is it's probably just like I need to do this. Message is basis messaging message. And same thing with this guy. Like so. And now in post init, we can do self message node on message received is that would be message node and message received delegate. And init, you can init as just a standalone function or as a method. We want it as a method because it's supposed to be called on this very instance of the interaction manager. So receiver is self, and receiver type is self with a big S. And that's really just like a convention that I use, which is used, I think, at least in some places in the Zig standard library as well. This thing that you have like self, which is like sort of like C++ this, and then self with a big S is just a type def to this. So the type that we are in. All right, so now whenever we receive a message, this guy will get called. We still need to actually subscribe to some message categories though, if we want that to be triggered, and we can do that by calling self message node subscribe to message category, and then basis engine messages and message category, and it was avatar tracking, I think, was the category that we were looking at here in the so this one. So now we get set active avatar and clear active avatar. We can listen to those two, and that should be everything we need essentially. So here's a funky thing with Zig. You can see that in my snippet that I had these ignores input here, but I don't have the autofix here. So now if I go like const t or s equals message, and then I save this, we'll add the ignore for the s obviously, but it will just complain about this guy. So apparently the language server is set up so that if I don't have that, like now when I added the autofix and save, now it actually goes away. That's kind of a small quirk there in how Zig or the Zig language server is set up currently. So message. Now we want basis engine messages message set active avatar. So if I can remember the syntax for the Zig switch cases here. Clear active avatar, right? Like so, and then I need to do like an empty else here, something like that. Let's try to build this, make sure it builds. We haven't made any stupid mistakes, and we have okay. What error is ignored? Right, so that's not supposed to be. Yeah, that's kind of interesting. Yeah. Yeah, apparently the message node is not set up to work with the Zig error handling currently. So it wasn't wasn't happy with me when I had like an exclamation mark here in the return type, which means that this can sort of handle errors. But nevertheless, let's keep going for now. If you want, I can go into how that stuff works, but yeah, let me know in the chat if you want me to explain that further. Otherwise, we're just gonna go right on. Cohist in the chat says use Rust. Yeah, no thanks. I'm sure Rust is wonderful, but it's not for me. At least not right now. Right. Where were we? We were in the interaction manager. Okay. So we should be able to just print something here if this is actually now called. So avatar, let's make this sort of visible in the noise of messages. Avatar set a new line, and what? Oh, yeah, N missing. So we should be able to see avatar set pretty quickly if we actually run the game now, because the avatar will be set essentially immediately. Look at the output for the game. You can see here, yay. Right. And if we set another avatar, we can see the avatar being set again. Right, so that works. Okay, cool. That's good. And now we can essentially do what the game master component is doing. I think that is probably what we will want to do here, because the interaction manager will need to keep track of essentially everyone's avatars. And if we keep a similar sort of hash map of the host IDs to avatar game object string hashes here, then this will work for multiplayer as well if we want to use the same thing with multiplayer. So let's copy the thing from the no, let's not put it there, let's put it here instead. So player data, vec3, we can just declare that as well. So it's basis math, vec3, last known position. Yeah, this comes from the game master. That could be kind of useful. Let's comment it out for now though, because I will probably need it later, but I won't need it immediately. So let's create that hash map. So player datas, that would be std auto hash map, and the key is an integer 32. So this is essentially like an int in C or C++, and player data, like so. And then we need to initialize this guy, and we can do that with probably like player datas is std auto hash map. I mean, we could like type def this if we wanted to, but oh, not array hash map, sorry, auto hash map, and then we can get rid of these guys. And we initialize it with an allocator, and we should get one from the host, I think. Let's make sure that we do. If not, then we'll need to pass one down to here. But yes, that's fine. Got one from the host. And in the dinit, we need to dinit it. like so. Kind of feel like the for some reason the language server is kind of acting up, but it does seem to be alive. So okay, good. Okay, good. Then what we can do here is I'm just gonna copy paste this from the game master stuff. So we have essentially, complaints about these things again. We don't have a context here, but we have something called on client. So we just want to check like if we are not on the client, then we get the avatar host name hash and get the player host ID. We create one of these player datas. We don't have that yet, so let's comment it out there as well. Now, if the player data already contains something for the player host ID, then we remove it. Otherwise, we put it in here and we ignore any errors for now. That's fine. And then when we clear the avatar, then we do this. And again, we want this if not on client thingy. So this just means that if this message is sent, someone gets assigned an avatar object. And then they get assigned another avatar object. Then we just clear like the previous value here and give it the new one. I think the system should be set up so that it sends like the clear in between, but it's probably a pretty good thing to have these guys here anyway. Right. Okay. So now we can make a helper function for ourselves. So I have the RPCs here in their own section. Let's put this beneath those. So function. And so basically, we want to know if we have a game object that enters one of these areas. We have this game object pointer coming in here. We want to know if that thing is actually an avatar or not. So we can do something like function. Essentially what we want to do is we want to get the host ID for the player whose avatar that is. And if it's not an avatar object, then we get like an invalid host ID. And I think we have something called networking here. So we have the server host ID, we have an unset host ID, which is like an integer 32 minus 1. So this is what we want to return if it's not actually an avatar object. Yeah. Okay, so let's do that. This is sort of searching from the hash map backwards, like we're using the value to get the key in the. Usually you go the other way around. Maybe we'll want to actually change that at some point, but let's go with it for now. Right, so get host ID from avatar. And this is just straight up the game object pointer. We can get the name from there, and then we can hash the name to get to the hash. So maybe we'll probably just do like self, const self, that's like the this pointer. And this is essentially like a const method when you put the const there after the asterisk. And then we have the avatar name hash. And this would be like a basis string hash, like so. And then it returns an I32. So now we can actually go into the code for the auto hash map. This is one of my favorite things with Zig, actually, is that the code for the standard library is actually quite readable, and in particular, they have these tests at the end, which actually just sort of shows you how to use the thing quite nicely. So we have like clear retaining capacity, and then it tests it out very nicely. So because our use case is slightly weird, we're sort of iterating over the values here. We're finding by value, not finding by key. I was thinking that we can there's probably something that we can use to like iterate over these guys. All right, let's search for iterate. Iterators. Iterator. Key iterator, value iterator. Okay. Okay, value iterator. Invalidated if the map is modified. We're not going to modify it. How do we use one of these guys? And then we can search for the whole. I mean, I can probably figure it out, but we can search for the whole, through the whole standard library to find these things. And like, yes, okay, here we have a use. So this large allocations is it's not necessary. It's a hash map unmanaged, so it might be the same type or not. We get the iterator out of it. Then we use a while loop to get a large alloc. Okay, this looks roughly like what we want. Let's try that. So we go into our newly created function, and we do var it equals self player data's value iterator. And yes, I am aware that like we're most likely going to have just like one player here, right? Or like even just maybe like 2 or 3. So it's a little stupid to actually use a hash map for this. I could probably just use a standard vector and do like a linear search. It would find it almost immediately. But hey, we can use hash map for all kinds of things, and now we can learn how to use them. So maybe I'll change this later, but okay, let's call this like entry. So what is this guy? This is a player data. Hey, it's a player data pointer. Okay, cool. So we'll do not kibst, but or actually we don't want to go there. We want to go here. We want to go const name hash is what was the thing we actually? Yeah, it is actually already the name hash, right? Okay, yes. Yeah, okay, so we don't need to do essentially anything. We can just do if entry avatar name hash equals entry. No, sorry. Equals avatar name hash, which is like that guy. Then we return the entry. All right. Yeah. We don't get the key from this, do we? Yeah. Yeah, we only get the player data. That's not nice. Okay. Well, I'm convinced this is this is not the correct place to use a hash map. Let's just do std. Actually, let's do host ID. So this is the thing that we used as the key previously. It's supposed to be an I32. We can use an array list of player data. Player datas. Yeah, this is the better option here. To use an array list of player data. So this is like your stud vector, but in Zig. Right. And now we can just do for self player datas. I'll call this like PD player data. If PD dot it's confused because I need to do items, right? Items is the slice, yes. If pd dot avatar name hash equals avatar name hash, then we return pd host ID. Yeah, and if we don't, then we return basis network unset host ID. All right, wasn't that easy? It was so easy. And now we just need to actually go into here and do the same thing. Actually, like, is there a remove with like a predicate player datas remove ordered remove, right? Okay, we need to find the thing first. Yeah, can we like find by? I'm pretty sure there's some elegant way of getting like the index for the element that we want to remove here by the host ID somehow. Not sure what that is though. Let's go to the code here and see. Find undefined. Okay, that was not helpful. Remove from end, remove from middle, yeah. Replace range. Yeah. Yeah. Alright, well, let's not get bogged down with this thing either, because it's kind of simple to just do a linear search through it. So we can again do self player data items pd if pd oh, and yeah, here we'll actually want to do 0 period or dot, and we'll want to capture another value, so the index of this, right? So if pd host ID equals host ID, then self player datas remove, and we can do a swap remove that is more efficient at I, right? And this probably returns something, right? Yes, it returns the value, so we don't need that value for anything. We can just ignore it like this. Okay, so that's that. Then we have this thing here, player host ID. Yes, this probably will want to have the host ID as well. So we'll put it in player host ID, like so. And yeah, now we want to actually either find the thing in here. We don't want to remove it, but alright, that's the new one. Okay, we can just comment that out for now. Right, so if we find this thing, then we want to actually update it. So we want to set PD. We actually probably don't need the I here this time around. So PD avatar name hash is avatar object name hash, which it is called there. Yeah. And then we can break the for loop. And I'm gonna do something like var updated false, updated true, and if we didn't update it, then we take this guy, get it here, uncomment the thing, and here we can just do self player data append pd and catch unreachable, something like that. It's not super elegant, but it works. Let's make sure this builds. It does not. Cannot assign to constant. All right. Okay. I need to. I think I need to do that. I might have to do another thing, but we'll see. Now that should probably work. Yes, that worked. Okay, so by default, when you capture something without like this star here, you actually essentially get like a capture by value, so it's a constant. And if you want to modify it, then you need to put in a star here. And if you do that, if you iterate over like a raw array, then you need to put in like an ampersand there in the beginning. But we're not doing that. We're iterating over a slice, which we can see here. So that works. Okay. Right. Now the interaction manager knows if we are the one who entered the area or if something else entered the area, right? So now we can do here in the object entered interaction area. We can do first of all we can hash the name. So we can do name hash is basis string make string hash object get name, and we get the autofix there. Yeah. All right, and then we can do const in blah, 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 blah. Host ID is the thing I want. And we get host ID from avatar, and yeah, we want to call it on self. Get host ID from avatar, and we give it the name hash that we created. And if host ID is basis network unset host ID, then we can just print this thing here, right? But if it is not, then what did I do? If it is not, then we know that this is actually an avatar, so we can do like avatar entered, something like that. Get rid of those guys. Yeah, this should work. Now we should be able to differentiate between avatars and non-avatars. And we can try that out by just spawning new things inside of those areas. Okay, so let's keep an eye on the output. Let's put in a new vehicle here. I'm going to put in like a truck. Yeah, oh, that's the huge truck. Get rid of that. Let's see. Okay. Yeah, doesn't work. Oh no, it does. Yeah, it just it just comes here. I was looking at the wrong output. But yeah, we actually did print them here. So now it says avatar base test vehicle 1 entered the interaction area. Yes, that's good. And if we spawn another vehicle here, it just says spawn and then some random generated thing without the avatar. Okay, good. Now we can get rid of those. And now again, when you drive in, it says avatar. Yeah, okay. Cool. Yeah, I don't know what's up with the frame rate here. Probably has something to do with my recording or my streaming or something. It's a bit weird. Okay. Cool. So that works. that means that oh no, not that one. That means that now when we actually get here, this is where we want to sort of take it further. So we can do like get rid of this whole thing. We're only interested in this if we are an avatar. And currently it's sort of like the host ID would be the same for every object that is an avatar in a single player game. If we wanted this to work in a multiplayer game, we would need to actually we would need to actually separate out those avatars and keep track of who is actually entering these areas. But we don't need to do that now because we're only concerned with single player currently. And of course, when we're exiting, then you know we want to actually hide the message. So if we go to the RPCs, we have this hide interaction prompt. We could probably just actually send these. These actually do take the player host ID as a parameter, so we might as well just pass them along, even though we don't really use them for anything, but we might use them later. So let's start with the exiting, because that's the simpler thing here to do, and we can just call self. And now we are calling an RPC, or we're making an RPC. We're making a remote procedure call. And as I explained, those go through an RPC proxy. So we call RPC proxy dot hide interaction prompt. And the player host ID is quite simply host ID. And let's keep that there commented out for now. Might be useful to debug things later on. And here we can do self RPC proxy show interaction prompt. We have host ID again. So interaction type, this is an interesting one. This is something that came from Project Slide when we looked at the code earlier. I'm quite simply going to declare a variable here for it and set it to 0, like this, just so that I know what this is, and I can even put in like a to-do here for myself. Because we will have different kinds of interaction prompts. Switching vehicles is one. Riding or ordering the mini, not the mini, but the monorail to arrive to your station is another one, etc., etc. So yes, we will want those as well, and then we can give it the name hash. But for now, we're just going to set this to 0, because we will just show some probably test message on the screen. Okay, access denied, and again that's why, because I have the editor running. So unload that, and it succeeds. Okay. All right, so let's review what we have now. Now, when an object enters an area, an interaction area, on the server, this thing is fired. We check if it is essentially the player's vehicle. I mean, that is what this get host ID from avatar means. If it is the player's vehicle, this will be true, i.e. this host ID will not be unset host ID. We're still on the server, but we're calling this through the RPC proxy on the server, show interaction prompt. That means that this will actually fire on the client, this function here. And this is where we can then take things a bit further. So what we can do now is put in like, left the B out. We can do something like entered, and then we print like a string here. And then in the args, we do if self on client, then client else server. I think that should work. Yes, it does. So this should now print entered client. And that should mean that our RPC has worked. I need to kind of test these things because I haven't done much, well, essentially any gameplay programming for quite a while. So I need to make sure I get these things correct before continuing. And you can see entered client, yay. So the logic runs completely on the server, but we do get this thing on the client as we expected. Okay, so that's nice. Now we can progress. We can move on to the next phase, which is actually showing this thing on the screen. And if we look at how we did it in C++ earlier, we have the interaction manager here. Show interaction prompt. So this checks the type that we currently just set to 0. It checks the type. It sets actually current switch vehicle target. Yeah, this probably is set to 0 in all other cases, and if we are here in the switch vehicle case, it is set to an actual proper value, and then we send a message. Let's check where this is used. Right. Okay. So this is used to draw that green circle that we saw earlier, using just quite simply debug draw Y circle, and at the position. So it draws it like just around the vehicle that is currently highlighted. Okay, we don't need to do any of that currently. So we essentially just need to send a message here. HUD show interaction prompt. Okay, that's cool. So this is probably in the HUD category. Yes, it is. Slide HUD. We do have messages here in Zig as well. So game messages. We have HUD. Init vehicle HUD, init vehicle HUD, init avatar role screen. So these are the only ones that are in the HUD category currently, but we can add more. So let's add like show interaction prompt and hide interaction prompt. Right? That's what we call them. Yes. And these guys would probably have like parameters along with them to tell the HUD HUD code, like, okay, what kind of prompt are we showing, etc., etc. But for now, I think these will suffice. So, before we start sending them though, we need to register them. So if we look for init vehicle HUD, we can find it there, and we can find it here. Here we actually register the message. So game message, show interaction prompt, and category is game message category dot HUD. So these messages are really kind of very low tech in their implementation. They don't carry any parameters themselves. They are essentially just let's see, where is the we go to messaging. A message is really just a 32-bit integer. And the nice thing about this is that it does work with C++. Like Zig and C++, they don't really talk to each other all that well. I mean, nothing really talks to C++. You have to go through the C API. Because the C++, or not API, but ABI, so the binary interface. But if you have something as simple as a 32-bit integer, those can be just very easily sent back and forth between C++ and Zig. So that's kind of nice. These kind of feel like kind of cheap, kind of old school, a pretty old school way of sending messages. But it has the benefit of this, for example, here, where we are listening to the active avatar, and when the active avatar is being cleared, because this is just C++ code actually calling this, and we can just straight up listen to them here in Zig. So that's nice. Okay, so now that we have them registered, we can send them. So we have the self.message node send message, and we use what is it? Is it game? No, it's probably like means game messages, and then show interaction prompt. And I think that's the only thing that it takes. Yes. Yeah, and we will pass these on later on, but for now we're just gonna send that. And the same thing here for the hiding, means game messages, game message hide interaction prompt, like so. And I think like the in-game, what do we call it? In-game UI view model. This probably already listens for HUD messages. I mean, that kind of makes sense because this is a HUD thing. No? No, does it not? Subscribe to, yeah, it does subscribe to HUD. Where are the HUD messages though? Yeah, it subscribes to the category, but doesn't actually listen to any of the messages. That's weird. Well, it doesn't really matter. I need to put it somewhere though. Do we have any commented out HUD messages here? Not really. Okay, well that's fine. Let's put them here. Player died. Not sure we're actually gonna die in this game at all, but let's see. So game messages. Show interaction prompt. Call as int. To convert it into an integer. And I'll add a comment there just so that it doesn't fold that thing. Same thing with the other one. Hide message. Like so. And then we need to actually, put something on the screen. So how would we do that? Well, if we go and have a look at what this guy has. It has an in-game state. It can be an in-game pause menu or game over menu. So yeah, in particular, we're interested in this HUD view. The HUD view is a Goofy UI view pointer. So Goofy is my UI library, framework system thing, which renders UI elements. There's a whole video on it on the channel if you want to know more how it works. And a UI view is quite simply something that can hold like controls and whatnot. And let's see how this works. So we have I'm just going to go through where it actually is used. Right, so when we go from a state, we like remove it from the stack, and then when we switch to the new state, we push it onto the stack. You can have multiple views active at the same time. They're sort of sitting in front of each other. And then we have a few things here that actually use the HUD view. So we have the avatar role selection screen. This is something that I actually developed on video. Not on stream though, but on video previously. HUD message queue, full screen animation player. Alright. Yeah. So yeah, we'll probably want to have something similar to this. These are not terribly big, but and the thing that we want to actually create for ourselves here isn't terribly big either. But they can get quite complex by the end. I think this is probably the closest thing that we have. So this is the HUD message queue. You can use this to play like show subtitles, for example. Let's see, I have some public functions here. So push dialog line. This is essentially a subtitle. You can also push messages. Maybe we could just push a message with this. Let's try to do that, actually. See what happens. Yeah, mission started. Yeah, okay. Yeah, this probably will get us at least started. Right. So, HUD message queue, push message, title text. Right. Time before showing. Okay. Yeah, so this should just be like immediately shown and then hidden. Yeah, we're not going to actually use this for the like final interaction texts. By the way, it's just something to get us started. So, what do we give as the title? Like let's try something out. Like let's do interaction area. Press E to interact or something. Like, no need to think about it all that much. Can I actually like clear it? I can clear the mission guidance text. Yeah, this is clearly not sort of supposed to be used for these kinds of things that are sort of stay on the screen and then at the very specific moment. So in this case, when you exit the area, it's supposed to go away. Yeah, we actually like by default we set the time to leave here to 2 seconds. So okay, well we can try this out and see how it works. Maybe we'll actually start to error is ignored. I have to do try probably. Nope. Does this not handle? Oh, it doesn't handle problems. Alright. Alright, then we need to do like catch. We need to catch the error like this. And then we can do like basis fatal error with name. I give it the source location and the error itself. Yeah, you can see here previously I've just used like an assert here, but this is perhaps a little better. Just unload that. And we can try it out. So now when we enter this, well, first of all, we can just put some vehicle inside of it. Nothing should happen. Now if we go into it, we should get a text, but we don't. Oh well. Oh well. What did we do wrong? Unload that thing for a bit, and let's let's see. Show interaction prompt. Yeah. Yeah, do we actually get here? So debug trace got here. And that will be shown in the bottom right corner. Let's make sure that we actually get here. Show interaction prompt. Let's search for that and go to the interaction manager. Yeah, we send the message. And we did get here, so that should be fine. Really, the next stop should be then here. Okay, let's see. It's a bit peculiar, but I might be missing something. Okay, so this corner here should now be like, yes, we did get there, so to speak. So why did it not actually show the thing? Why did it not show the thing? Message queue. Gets put in the message queue. That's strange. Let's make our lives a bit easier. I'm just gonna quickly export this guy. Export, boom. Exports in no time. Now we can just run the game. We can go here to launch. We can make sure that we're actually playing. Prototype test level is probably not the correct path though. It's supposed to be refinery blockout. Oh. Yeah. That happens sometimes. My clipboard is somehow occupied. Yeah, that's annoying. Right, what is the path to the level though? Means here we go, and we go here, and we convert that, and that would give us the path. There we go. So this is the level that we want to run. Right. Okay. So now when we play this, we see we get the got here message, which is what we want. And now we can actually try to debug this thing. Let's put a breakpoint in. Not this actually. It's the HUD message queue, right? It's this thing. We do get there, so that's good. Okay, that's fine. So I want to see if we can go into show message internal, which we should get into, but yeah, we actually don't. If message is larger than 0. Oh, so it should be like time before showing is larger than 0. Okay. Okay. Yeah, it should probably just be like that. It's a very slight bug in my HUD code. There we go. All right. Yeah. So now the problem is that it does go away after 2 seconds. Like if we now exit it and then we go back in, it again shows, yay, interaction area. But then it goes away, and it's obviously like it shouldn't do that. But it also shouldn't be that in your face, right? It should probably go like be somewhere down here in the lower corner or something like that. If we switch to the monorail avatar, and yes, we don't have any collisions for the ramp still, which is kind of looks a bit stupid. Now if we enter this, we get the E. Press E, which of course doesn't do anything yet, but that is the next thing to handle. Yeah. All right. Yeah, let's do one more thing today. I'm gonna go get some like tea or coffee or something, because I'm sort of all this speaking and talking is making my throat kind of sore. So I'm gonna do that, and then we're gonna do one more thing. We're gonna create like a text that stays on the screen, essentially like the beginning of the actual interaction text system, which I'm sure will look wonderful when we get it to finished state. Today we'll just quite simply show a text on the screen for as long as we are inside the area. So let's do that. I will be back in a second. I'll be back in a second. I'll leave a note here on the screen. Back in a sec. Make that large and nice. If you have any questions in the meantime, write them in the chat, and I'll get to them when I get back. All right. Let's get back to it. And we have a question here. And it's an excellent question, actually. What kind of benefits do you get from having a standalone asset server, not having the client directly load assets from the file system? So you get multiple benefits, but there are, of course, pros and cons as with any system. So, so this asset server thingy here, as you can see, it has a log, which essentially just like prints out what it is doing, and it also has these other tabs here: conversion output, conversion error output. So first of all, you get to have the same. You get to have your conversions for all of your running games, even if they are sort of the same game, just running multiple times. As for example, like if I run the editor here, load the editor back in, this is actually running the game now. You can see here in the asset server that you get a client login succeeded, host ID 3. Maybe I can make this slightly bigger. And now if we actually play the game, we start like a running instance of the game itself. Now we have another one, host ID 4. This server also serves other completely other game projects that I might have with the basis engine running on my system. And you get to have sort of all of the conversions and everything happening in one place. So depending on the asset that you are actually talking about, it may or may not require a conversion. And what is that? Well, if we go into the means data, for example, we have an underscore script. We have a pipeline Lua script here. This is actually, I don't really use Lua anymore, but the script is still Lua. I rewrote the parser for this. So it's a completely custom parser that actually runs and executes these things now, but the syntax is still Lua, and I still use the Lua extension because that gives me the nice syntax highlighting and everything. But if you have like a PNG file, for example, let's search for PNG. This script is read by the asset server, and it registers a PNG texture operation for any PNG file that we have on the file system. And what it does is you get to specify like the texture converter exe path here. Again, maybe I can make this a bit bigger, right? There we go. So it runs a texture converter with the input file, some like temp folders, blah blah blah, and then out of the thing that it converts it to, it generates a resource file. And so PNG files are converted into .tex files. For example, here you can see the .tex is the output from the generated resource file. Same thing with JPEG files, for example. And we have, well, JSONs are they're just pre-processed basically, so we can verify if there are like JSON syntax errors and things like that here, and give you an error in the asset server window rather than have the game do it. Then we have some things that we ignore, and then we have some things that we just copy over directly. So things like XML files apparently get copied over as is. And so that means that you can just do all kinds of things in your converters without having to have the game actually contain like the code that does the conversion for you. But you also don't have to run this converter like by hand. You can just have the asset server run it for you. And of course, one benefit is that having file watchers, anyone that's ever written a reliable file system watcher knows that it can get kind of hairy, and there are lots of like tricky edge cases and things to keep track of, and it's kind of nice to just get to stuff that all out into an asset server app like this, and not have to have all of that at runtime, because it's kind of it's not very nice to have to do that at runtime, but of course it works if that is how you want to do it. So that's one benefit. Then we have the benefit of actually being able to like stream things off or like over the network. For example, when I run the editor here, let's open up another one. You can see here that we have the work folder root file here, and we are essentially, well, that's actually kind of like a bad example here, because we don't actually specify any server address here, because with the editor the asset server is always assumed to be running on the same machine. But if I had like a texture converter that only worked on Windows, that converts like PNG files from the source format into text files, but I want to run the game on a Mac or like a Linux machine, this thing is actually like a proper server, so you can just stream the data completely over the network from this guy to any other machine in the local network, even like a PlayStation or an Xbox potentially, if you are developing for those. It does cheat a little bit and just quite simply send the converted file paths to the running game rather than sending the data if the server is running on the same machine as the actual game. So just makes it faster to do that way. But you can potentially just stream all the data over the network connection. So that's that. And then finally, you can actually just have we can generate pack files, for example. So here we have now currently just one game loaded. If we load the slide data, so project slide, this should be kind of quick to do actually. So now we have two of them. We have means data here. It's a bit small to read, I know, but we have means data and we have slide data, and now we can just generate pack files from means, for example. And I just put these in on like desktop and like test packs. And okay. And now we just packages everything together, so you can just take the exes and the asset server just creates everything fully for you. I think this might crash. Let's see. Yeah, it crashes. Out of memory. I need to fix this. It shows you some beautiful graphs of the data that it created, but doesn't seem to work currently. So here we have the pack files for the Traction Point game currently. What is that, like 60-70 megabytes perhaps? And of course you can just build anything into your asset server application if you want to. But it is by no means like something that you need to do. You can prefer to have your game load stuff directly, then by all means. Then by all means you should do that. Okay. But excellent question. Thank you for that. Let's continue with what we were doing. So we get to play around with Goofy a little bit to get the text on the screen. I think the easiest way to do that is probably to add a new element. If we look at how the HUD message queue works, we have a few things here. We have a dialog line, a HUD message, and then getting some weird connection thingies from OBS here. Let's hope. And let's hope the the stream keeps going, at least for a little bit. Yes. Anyway, I think HUD message is the thing that we actually ended up using before the break when we had the message on the screen. And we can see here that we have the HUD view. We can get a widget out of it. In this case, we get a canvas pointer. A canvas is really just like the name suggests. It's like a thing that you can draw on. And it has a name HUD message. So if we go into the work folder root and we go into the game and UI and scripts and HUD view, we have the HUD message here somewhere. There we go. Create canvas. HUD message. And since we're just going to want to have a text, maybe we can be straightforward and just create a label. Let's make this a bit larger again. So the view can be created from code, or it can be created via a this kind of script. It's not super ergonomic to actually build these things because I don't have any do you call it auto completion or anything like that set up for this. So I try not to do super complex things in here, but it is kind of nice because this is hot updated. So we can copy this label, for example. Actually, maybe we'll actually use this hot updatable thing for this. We don't need the editor at all. I'm just going to shut the editor down and just run the game from VS Code directly, like this. Okay. And so now we have the script here. Let's create a new label here. We don't need to bind the visibility to anything just yet, but that is probably exactly what we want to do in a little bit. What happens if we just do it like test? Then we get test on the screen. Hey, how cool is that? And then if we move it off to the side a little bit, probably want to make it much smaller. Oh, smaller, I said. Something like that, but maybe even smaller still. I haven't designed this at all. So I don't know where on the screen it would actually sort of look nice. Maybe something like press E to interact. I mean, even the text is kind of silly currently, but just to have something. Just to have something. And we can use text pivots. Oh, there we have the pivot actually. Yes, so we can do left. Oh, that's not what it was. It's probably like center left, right? Yes, center left. So now if I put that to 0.5, it should be right in the middle. Yeah, the left side of this text is right in the middle of the screen. Excellent. So let's do 15. That's a bit much. Move it off to the side a bit more. I don't know. Maybe it is actually pretty all right. Yeah, we're working in normalized coordinates here, so I don't know. This all looks kind of weird to me. I'll tell you what, I'm gonna move it to the center, make it somewhat small, just like it was in Project Slide. Yeah, that's fine. And yeah, I think that will probably work. Oh, all right. Probably something with this hot reloading, and we even had a script error at some point. But cool. I think that's fine. So now we just want this text to show up whenever we have the right conditions. And like you see here, we can actually bind the visibility to properties. So we have a HUD/go label visible. If we search for that, we can find it. We can find it in some place. Register property. So this is probably just a string. There we go. So let's add a new one here. We can do UI. Oh, that's minigame. Yeah, that's stupid. Let's not do that. Let's add like at least like a new line there to separate that from the minigame ones. Yeah, there's a video on the minigame that I built during like one of the transmission videos. You can find it on the channel if you want to know more. But we'll do UI HUD interaction prompt visible. And these are just strings. They're strings just mainly because if they are strings, then we can put in the same string here in the script as well. Like so. And now we need to register the thing. We do that here in where are we? We are in the UI manager. So Goofy manager register property, and it is a boolean. So bool. Property name is means.UI constants.UI HUD. What do we call it? HUD interaction prompt visible. Initial value is false. Right, so properties can be, what can they be? They can be like floats, integers, vectors, colors. So you can bind like a position of an HUD element to like a property, and then that property needs to be a vector too, for example, things like that. Yep. And now that we bind this to a property, we don't actually necessarily even need to do something, to do anything more complicated. We can just set that property in the in-game UI view model. So back to where we actually listen to these messages. Rather than doing the push message here, we can do Goofy manager set property value of type bool. The property name is the that means.UI constants. What did I call it? UI HUD interaction prompt visible. True. That's it. That should make the thing appear. And then when we hide it, we just set it the other way around. False. Yeah, we have some old crap here. Oh, that's we have some old crap there because I'm in the wrong message. That's not the one I want to be in. It's right there. Yeah, but lots of things here that I've sort of tried out and then just kind of left there. But I should do a cleanup pass at some point. Okay. With a little bit of luck, that should be everything that we need. See if it works. Hey. And when we exit, it goes away. So we obviously we need to like tell the player like press E to do something. Not just interact, doesn't really tell the player anything. But if we have like, let's put down a vehicle there, and we can set it as the avatar. Here if we drive to the monorail station here, and you enter this area, there should probably be some sort of like boom or something, like boom gate here or something that prevents you from falling down. But yeah, now if you press this, then and the monorail is in the other end, it should start coming this way. I'll probably also need to like change the color here when that happens, etc., etc. Lots of things to do. Lots of things to do. Yeah, and I need to properly model this ramp so that you can't fall through it. And then once you're in here, this should probably have an area as well. And then when you actually interact with that, then it will start the monorail, and you can ride in the thing. Okay. Okay, cool. Yeah, maybe that's it for today. This got kind of long and kind of rambly, especially in the beginning, before we really got started with these things. This is typically the case when I haven't really done any gameplay programming for a while, and I get back to that, then I just kind of don't remember how to do anything for a bit. Let's try one thing. If I have this guy, set that as my avatar. And then like, how should we do this? Set that guy as the avatar. That gives us a command here that is run. GameState.setAvatarPlayer0. We can copy that in there. If we go back to this guy, and then we run that again, we can switch back to this quickly. So now if we pick up speed and we drive into the area, or towards the area, like now if I switch to that guy, yeah, we don't get the text there. But now that we drive this guy into it, we do get the text. So we can see that our avatar tracking code is actually working. Nice. Nice. Okay. Pretty good. All right. Any questions? Do we have anyone left? A couple of guys still left, according to my stats. Do you guys want to see more of this kind of live thing, or do you prefer a more prepared for video? Do let me know. Do let me know in the chat, or do let me know in the comments later on. I'll probably put this up as a VOD as well. But yeah. This was a whole experience. I haven't done this live thing before. What would happen if you were in the interaction area and then switched avatar? That's a good question. I bet it bugs out at least a little bit, because we don't actually leave the area then, right? Let's see what happens. Let's put down another car, because that one that just drove off probably fell into the abyss. Right, so if we put down a vehicle here, then we drive into this guy here, and we get the interaction. All right, and then we switch the avatar to here. Yeah, now we still have the press E to interact thing. So excellent observation. Yeah, it doesn't. Now we're back on track. Now if I drive out, it goes away. And that's not actually even the only thing that we need to still track here, because like, what happens, for example, if I do this, if I come close to this truck here, Now we're inside an interaction area, and we also, according to my game design, we should be able to switch to that vehicle even if we can't really do that yet. We have sort of two interactions at the same time, so we need to probably allow them both. Like I was first thinking that we would have some sort of hierarchy, or we would sort of rank. Would have like a ranking, like which is the more important interaction. But I think we actually need to support all of them. So we just quite simply have to reserve a few buttons. So we have like a primary and a secondary interaction or something like that we can handle, because you might want to specifically not change vehicle but activate the area. We'll see. It's not the most elegant game design, but it is probably quite important to handle that. Anyway, good question, good observation. Could we actually handle that particular case in some easy manner? Probably not, as long as we as we drive the whole thing from those physics enter and exit events. Like the whole thing starts with these guys. But what we could do is keep track of all the objects that enter an interaction area. And when this message fires, we check this avatar object name hash, and we check, okay, is this object already inside one of these areas? So there needs to be like an else here, or actually probably this is not how we're going to drive the whole thing. But yeah, that is probably how it needs to be handled. We need to do those checks when the avatar changes, and then just keep track of all the objects that are inside an interaction area. Something like that. Okay, cool. Oh, and then the mother vehicle has some other implications as well, of course. Like this guy. I was sort of thinking that you should be able to switch vehicles via this crane. So as long as you have a part of this crane kind of close to another vehicle, then it should probably work as sort of as an extension of your vehicle. So this is like a whole different thing. Currently, or at least in Slide, it works so that if your vehicle is close enough to another vehicle, then you can switch to that vehicle. And if the vehicle is friendly and you both are standing relatively still, etc. But yeah, I think this crane will need to sort of work as sort of like an extension of that whole thing. And so that you can sort of reach over maybe like a fence or something with the crane arm. And yeah, this thing is just completely crazy because the mass is just so offset here. Right. Am I planning a full migration to SIG? Probably not. Not in the foreseeable future, at least. I mean, I don't have any problem against I don't have anything against writing a full game in Zig, per se. The thing is though that I use so many middleware, so many pieces of middleware, and not to mention, of course, my own code. But if we're strictly talking about middleware, like all of this is driven by PhysX, for example, which is a C++ library, and so it's, even though Sig is very good at interacting with C libraries, something like PhysX is just like not that easy to interact with or interop with, unless you put a significant amount of effort into the interop code. But of course, in this particular case, I mean, I already have a game engine. The game engine has a full editor and converters and everything, so I don't want to throw that away. If I started from scratch, that would probably be a completely different story, and I might make a decision to not use PhysX for that kind of thing. But now that I am, and PhysX is powering all of this vehicle physics and everything, I'm unlikely to ditch all of that just to write something in Zig. That said, doing the interrupt things are sometimes a little annoying. I'm not gonna pretend they're not annoying to do. But yes, yeah, this game at least will remain a hybrid, or I should say probably this engine will remain a hybrid. I do hope Sig takes off like actually and properly though, and we can all write things that are more or less completely Zig. But I'm not like a language purist in any sense. I use whatever works for me, and so I'm not really waiting for that to happen. But I do hope Zig really takes off. It's a wonderful language to work in already now. Okay, cool. Do we have any other questions, or should we call it a night? I'm happy to answer anything if you have, but let's see, can I lift up this car onto this higher level? There's quite a bit of work still with this crane, even though we did spend quite a few videos earlier developing essentially nothing but this. You can see that it has collisions and things missing still. It is kind of fun to work with though, or like play around with. Yeah, only the tip of the crane arm has collisions currently. Yay. Which means that you can do some kind of interesting things, like flipping over the whole mother vehicle if you poke at the ground with it. At least if I remember correctly. Retract the cable. And then poke the ground. Poke, 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 poke. Yeah, I mean, I should really prevent this these movements from being done. Just sort of everything is just breaking. Yeah, I made the arm a bit shorter at some point, and now it's kind of tricky to do this, but you can flip it over. Okay. Yeah, maybe we're done for today. Feels like we did cover quite a lot. Anyway, let me know in the comments if you would like to see more live things. Can't promise they will be any less rambly, but maybe I can prepare my stuff a little better than I did today. And if you would rather have me do like videos on demand that I can rehearse and research a little better than this, then that's fine as well. But if you made it this far, thank you for your time. Do check out the channel, subscribe, like, do all the things. And what the hell has happened to this guy? Oh. Suddenly it got wheels. Anyway, see you guys later. Have a good one.